Okay, our next section in Chapter 5, 5.2, solving systems using tables or graphs. The big difference between this section and the last, we are no longer using inequalities in this section, and we don't have a compound system that would graph on a number line. We still have two or more equations, but they will not be graphed on a number line. They'll be graphed on a coordinate system. So you can see we're going to estimate solutions, talk about properties. So let's take a look. When we say solve a system using tables and graphs, we're talking about you should have at least two equations or inequalities. We're going to have equations. And you're going to be looking for where they share things. Share means intersection, we learned in that last section. So the intersection of our solutions of each graph should have something in common. If it doesn't, that's another piece we'll have to talk about. So, in our example here, solve using a table. If you had two equations in slope-intercept form, so we've got y equals 4x plus 8, and we have y equals 3x plus 5, you could tell me right now that these two are lines. You could also tell me they do not have the same slope. Their slopes are not even perpendicular like we studied in the last section. So we're going to get two lines that intersect. Where and how, we don't know. Now, because it says use a table, yeah, you could make your table by hand, but we've been using our technology. So take a look on your grapher, and if you graph both of these at once, 1 under y sub 1, 1 under y sub 2 on your graphing calculator, you should then see xy values. And these xy values should be recorded for each separate line. Now, if you haven't, go ahead and punch those into your calculator. I'll give you a second here to do that. So y equals 4x plus 8, and then y equals 3x plus 5. And make sure they graph. You can take a look at what they graph into. So go ahead and hit graph. You should see two intersecting lines. Now, the point is here, and it says solve using a table, we don't want the graph. We want the actual table. So if you go to your table, you're going to see all kinds of points, values that have been graphed, and we're looking for where they share a value, where they have the same value. Now the key will be you can't look at the x's, you must look at the y's. You're looking for where do they share the same y value, because you only have one x listed and it's a y value that we need. Now I believe it was over in the negative. When we look back at the graph real quickly, I believe it was over in the negative or the second, actually no, the third quadrant that it was in. So double check that and you have an idea that gives you a hint about where you should look. And so on your table, you should see, for example, -3, -4, and then a -4 also for y sub 2, where all the other y values are different. So looking at your table, you should say this one crosses at the point -3, 4. So the point that they have in common, the only point that they share, is -3, 4. And when you're looking at this, as I said, we have a graph. It's a fairly tight graph if you were looking using your calculator. One of the lines went down like this. The other line crossed it down in here. So that point, -4, is that one place where they do intersect. They are fairly tight lines as we would describe them. So using your calculator, if you want to plug in x values, then you want to be looking for where they share the same y values. So that's how you would use your table. Now, this one says solve the system by graphing. One of the two equations, if you look, y equals 3x and y equals 3 over x, looks familiar. The other one does not. It's not as common to us. But here are some things we want to remind you before we actually do this. It says you must solve for y in each equation, meaning if the equation doesn't have y by itself, which both of ours do, you would have to rewrite and get it. So that might mean an extra step, but get y by itself so that you can graph. Then go ahead and you would graph each equation. Draw the line, the parabola, the curve, whatever it is. From there, you want to find all points of intersections. There may be more than one. You need them all. Some of the solutions are exact solutions, and some of them are harder because they are only approximations. You can't see them very easily. They're decimals, fractions, combinations that are not nice whole numbers. And then last but not least, the number of solutions is greater than or equal to 0. Because truly, if you think about some of the intersections and the different graphs and things we've drawn over the course of just this year, they could cross at no points of intersection. An example of that would be our parallel lines. They could graph at one point, just like that last one. Two lines that intersect might graph at one point of intersection. And then, or more would be, we've had parabolas. If I take a parabola and I happen to cross it with a line as that is displayed, we could have 2 points of intersection. And depending upon what you're drawing and what you're intersecting, there even may be more than that. So keep in mind that your number of solutions has to be greater than or equal to 0. All right, on this one, again, clear your screen on your grapher. Go ahead and enter y equals 3x. We said that we should know that that is a line that goes through 0, has a slope of 3. The second one, y equals 3 divided by x. Is a slightly different looking graph than we've seen in a while. It's one of our hyperbolas. And when you graph this, you see that it crosses in 2 different spots. So double checking that when you did this, you had a hyperbola that was in the first and third quadrant, and then your line of y equals 3x crossed there. So you're looking at this one and saying, I have 2 points of intersection. 1, 2. Where do they cross and intersect? You could find those values, again, by going to the table, if they were nice values. If not, you could even approximate them by eyeballing them. You have some features on your calculator that allow you to do that, and you could also plug in your values by hand. When x is 1, y is in both equations. So you could do this by hand or with your graphing calculator. So when we solve a system, use or look for intersections only. Now, there it is in display. Better graph of what you should have seen. And notice that those points, where they intersect, are fairly nice points in this situation. This one and this one. So if this is counted by ones, we're looking at 1, 2, the ordered pair 1, 2. And here we're looking at the ordered pair -1, -2. Those are the points of intersection. They're the only points that overlap in this situation. So keep in mind you have your graphing calculator. You're expected to use it. Use the table as best you can to get to your solutions. Approximate when necessary. And remember, you're going to have more than one solution. Well, you're going to have solutions that are 0, 1, or even more than that, as in this case 2. So it depends upon what your graph looks like. You should be able to approximate them, and you could even check. Let's talk about that for a second. If you checked and they said prove or verify, so if someone said let's verify that our solutions are correct, you should be able to take your solutions, 1, 2, and -1, 2 in this case, put them back in the original equation. So if I did here, I'd say x is 1 and y is 2. And I don't know why I said 2, because it's obviously 3. Let's count. 1, 2, 3. 1, 2, 3. So make it -1, -3. Correct that. And we will now go and verify. Put our 3 in for y and our 1 in for x, and we get 3 equals 3. It made it a true statement. Put that same ordered pair in here. 3 equals, in this case it's 3 divided by 1, and that's 3 equals 3. So they both checked, and that's in the top equation. Now do the second point, which is -3, -1, and you have to be able to get the same thing. So verifying is just placing the ordered pair into your equation and showing that it makes both sides of your equation true. In the second one, it would be 3 divided by -1. We know 3 divided by -1 is -3, so it checks. So if you have to verify, that's what we're looking for. Okay? So with that, you should be able to solve these problems, do some graphs, and we'll come back and talk about any questions or issues you have.